Question. There are 2 points M and N in the rectangle ABCD. Point M bounces off the edge ADAD and DCAD and DC and CB of the rectangle and then hits point N. Draw the route from point M to point N respectively. So let's work on this. The key to this question is to make corresponding symmetry points for M and N for each case. Let's see case 1 bounces AD. We can get some inspiration from physics. Imagine that the inner walls of this rectangle are mirrors. A beam of light starts from point M and reaches point N after reflection on edge AD. Therefore, in order to get the path of the light from point M to point N, we must get the position of the reflection point of the light on AD. First, we must make the symmetry point M prime of point M with respect to AD, because theoretically, point M and point M prime are completely equivalent for light. Just like if we don't know that AD is a mirror, we won't be able to distinguish whether the source of the light is on point M or point M prime. Assuming that this rectangle does not exist, the light starting from point M prime will also propagate along a straight line and directly reach point N. Therefore, by connecting point N and point M prime and intersecting AD at point U, we get the position of the reflection point. By connecting point M and point U, we get the path from M to N after bouncing off the edge AD. Next, we look at the second case, reflections from AD and DC. In the same way, we only need to make the symmetry point of M about AD and the symmetry point of N about DC. By connecting M prime and N prime, we get the equivalent path, which intersects AD and DC at point U and V, so we get the reflection points. By connecting MU and NV, we get the solution to case 2. Finally, let's look at case 3, reflections through AD, DC, and CB. Similarly, make the symmetry point of M about AD. But it's a little tricky for point N. We must first make the symmetry point N prime about BC, and then make the symmetry point N prime prime of N prime about DC. Because of the light path is reversible for the endpoint N, the path has gone through 2 reflections of BC and DC. By connecting M prime N prime prime and VN prime, we get the reflection points U, V, and W on each edge. Finally, by connecting MU and NW, we get the solution of case 3. This is the Geo-Thinking channel. Thanks for watching. If you like my channel, please like and subscribe.